this project. Firstly, I will present the introduction part. The location of Mr. DIY is at number 3, 5, 7 and 9 Jalan Siakap 2, Taman Permata Pasir Perdana, ALIAH, Melaka. This store is operating at 10 AM to 10 PM every day. During our observation, the number of server that operates is only one server. The observation was done at 2:20 PM until 3:20 PM, which is 1 hour. Okay, next moving on to the characteristics of queuing system. Arrival characteristics. Firstly, we will discuss the size of the calling population. Calling population can be referred to as the population of potential customer. For our size of the calling population at Mr. DIY, it is infinite population. The reason is the arrival rate is not affected by the number of customers being served and waiting. The pattern arrival at Mr. DIY is random arrival, which means that customer can arrive randomly and was unpredictable. This assumption following Poisson distribution, and the lambda in our observation is 20 customer per hour. The behavior of the arrival is patient customer. This means that customer wait in the queue until they are being served. Okay, next I will go through waiting line characteristic. For the length of a line, the length of a line in Mr. DIY is unlimited since the arrival rate does not affected by the number of customer waiting in the line. Next, for queue discipline, the queue discipline can be referred to as the rule by which the customer in the line receives service. For Mr. DIY, they imply the first in and first out rule, which is FIFO. Next, moving on to the service facility characteristic. First, number of channels. Number of channels is referring to number of server available in the system. During the observation time, number of channels available at Mr. DIY outlet is single channel system. Next, number of faces. Number of faces in Mr. DIY is single face system. This is because customer need to go through one counter only, which is cashier counter, before they leave the store. For the number of waiting lines, it is single lines because there is only one server at Mr. DIY outlet. The pattern of service time in Mr. DIY is exponentially distributed. The mu is 44.44 customer per hour, which implies the cashier can serve at average 44.44 customer in 1 hour. From our observations, the basic queuing system configurations for Mr. DIY is single channel and single phase system. The customer will arrive and then they will queue in a line for paying their items, and then they will exit the system after finish the payment.
My name is FARHAN. So here I'm going to show the set data of customer that we observe in Mr. DIY. So this is the first page of the set data. So this is the second page of set data. So the set data of customer is consists of the number of customer, arrival time, start in the waiting line and end in the waiting line, and service time, how long that customer had been served in the waiting. So now we need to find mean number of arrival per period and the mean number of customer served per period. So firstly, we assume mean number of arrival per period as the lambda, and the second one is mean number of customer served per period, we assume as the mu symbol. So now, based on the set of data, we already knew that lambda is equivalent to 20 customers per hour, and now we should find the mean of customer that we serve for a period of time. So now while the number of customers is 20 customers. Then we take the both of value and divide 27 over 20 and we got 1.35 minutes. So we can calculate the application can serve the customer in average 1.35 minutes. So now we should find the number of customers that we serve per hour. Now take the previous answer, which is 1.35. Then we take the 16 divide by 1.35 minutes and we got 44.44 customers that we serve per hour. But this value is in the decimal, so we take the closest value to the decimal, which is 45. So we can conclude that the cashier can serve a customer in an hour. So that's all. To find the average customer that we serve per hour. So now let's go to the next slide.
Hi, so I will continue to find the value of L, W and LQ. So for L is the average number of customers in the system. So the formula for counting average number of customers is L equals to lambda per new minus lambda. So that is 20 over 45 minus 20 and we got 0.8. So the conclusion is there are 0.8 customers in the system on average. So that is the average number of customers in Mr. Awan. Next is the average time of a customer spends in the system. That is W for W. So for W we use formula 1 over new minus lambda. Then we get 1 over 45 minus 20, so equals to 0.04. So the average customer spent in the system is 0.04 hour in Mr. DIY. So every customer has been served in average time for 0.04 hour. Next is the average number of customers spent in the queue, that is LQ. For the LQ formula is the lambda power of 2 divides for new column new minus lambda, so equals to 20 power of 2 divided by 45 column in 45 minus 20, so we get 0.3555. So the conclusion from the LQ, that is the average number of customers spent in the queue. So the average number in the line Q is 0.355 customers. So every 0.04 hour there will be waiting line for 0.355 customers that will be waiting. So now we are going to continue to find WQ, P and PO. So the average time for a customer that is WQ is based on the formula lambda divided by new column new minus lambda. So we substitute the value that we got, 20 divided by 45 column 45 minus 20, then we got 0.0177. The conclusion we get, the average waiting line for the customer is 0.0177 hour in Mr. DIY. So a customer will spend 0.0177 hour in Mr. DIY's queuing to pay or to be served at the counter. Next, the utilization factor for the system, P. So we're gonna to calculate the probability for the service is being used in Mr. DIY. So the formula for calculating the utilization is lambda per new. So substitute the value that we got, 20 per 45, and equals to 0.4444. So the probability the service is being used is 0.4444. Next, the percent idle time, P0. The probability that no one is using the system. That means no one is in the system, no one is queuing. So we're gonna be equals to PO equals to 1 minus lambda over new. So we will get 0.5556. In that case, the probability that there are no customers in the system or the servers are 0.5556. So that's all for calculation for waiting line for Mr. DIY. Thank you.
Next, the last one is conclusion. Give a comment on the number of servers provided and the customer waiting time. Is the number of servers provided adequate? The answer is yes, because the customers are served at a faster rate than they arrive. Next, are the customers are being happy with the waiting time? Yes, they are happy because they are being served on time. Next, describe what you have learned from doing this project. While doing this project, we had learned that if the average service rate is greater than average arrival rate, it shows that the customers are served at a faster rate than they arrive. If the average arrival rate is greater than average service rate, it shows that the queue will be larger and the waiting time will be longer. Thus, the service will become slow. That's all from our group. Thank you for watching.